So let's talk about ACI architecture. So basically what we have here is a traditional architecture, which is something like your core aggregation and access layers. In a traditional data center architecture, what we have are servers which are connected to access switches. Access switches are connected to aggregation switches only, which means that they cannot really go directly to other access switches. If there is a need for routing is going to be done through aggregation switches most of the time. Also, we can have some core switches up there, and these core switches can be used for different things, for example, for southbound traffic, northbound traffic, or something like this. So this design has some problems, and some of the problems that we can have is here. First of all, the design is not scalable that much. It is scalable, but not that much. I can have more access switches and they are going to be connected to aggregation switches. But first of all, you can see that the number of links that we have is not going to change that much. It is not going to give me more bandwidth, for the switches that I am adding here. And, managing those devices which I am adding here is going to be a problem. That's going to be a problem because I need to go to each switch and start configuring those switches. So instead of going for this type of a design, what I need to do is to go to this type of a design, which is going to be ACI design. In ACI design, I have only two layers, first of all, which is going to be a lot nicer. These leaf switches are going to be my top of the rack switches, and the spines can be put in another rack in the end of the row, and then all the leaves are going to be connected to spines. All the spines are going to be connected to leaves. Each spine is connected to all leaves. Each leaf is connected to all the spines, and this one should be leaf 1, and for some reason it doesn't just change what I have written. Leaf 3, of course. So basically, you do not really connect leaves to each other. You do not connect the spines to each other. Otherwise, that spine is not going to work. It is going to shut down. Now, where is the scalability here? Let's say that I want to have more leaf here. So I'm going to select this one only. I'm going to copy this and paste it here. Here, I'm going to, of course, delete all of these. I just wanted to have one of these. The bad thing about using yes, let's go with this. That is much better. So I have another leaf here, and this leaf is going to be leaf 4. And what I need to do is to just connect this to all the spines that I have, which is super easy, of course, right? Where is my pen? Okay. So what I need to do is to just connect it to all the spines that I have. This is one of the connections. This is another connection. That's it. Which means that anytime I add a new leaf, that's easy. Just I have connections to all the spines. Anytime I add a new spine, again, that's going to be easy. I just connect it to all the leaves that I have here. Now, let's see what we have. We have 2 spines, which means that every leaf is going to have 2 paths at least to these spines, and from these spines to the leaves to the destination. Let's say that, for example, I have a virtual machine which is connected to leaf 1. I have another virtual machine which is connected to leaf 2. If I want to have a traffic from VM to VM, what is going to happen? It can go through a spine and then to here, or it can go through this spine and then come to here. So to the number of spines, I have path to the destination. So if I increase the spines, then I will have more path to the destinations. The second thing is I only need to go 2 hops away to get to the destination. So my traffic goes from a leaf to a spine, then to the other leaf, and then it is in the destination. So it doesn't matter which path it takes, it is only 2 hops away from the destination. So what we have here is 2 things. First of all, scalability. This means that I can add extra switches at any time, and I can have redundancy, which means that I can have multiple paths. If I increase the spines, the paths are going to be increased as well, which means that redundancy is going to be there for me. And of course, I will have performance because I can easily manage these switches from one source. That is going to be my APIC, of course. And you can see that the bandwidth is there shared for all the devices, and you can use it to your benefit. So we have these benefits for our ACI architecture. Now, if I just go back to here, you can see that I have 4 spines in my topology here, 5 leaf switches, and 1 APIC, which is going to, manage all of this. And you should know that when we speak about this type of a topology, this is going to be called fabric. So I can say APIC is part of the fabric, but most of the time you can just say this is a management device and it is not part of the fabric. The actual fabric is this part, which is the connections between leaves and spines, and everything should be managed in here. So let's say that we do not really talk about APIC here. APIC is going to manage them. So all the spines and all the leaves and all the connections are going to be our fabric. So these are the components that we have here. Now, like I said in previous videos, this kind of a design is very much application centric. Later I will speak about this and you will understand what I mean. The other thing is we have support for non-Cisco devices, which mean that ACI is an open source and a standard type of an application. Not kind of an application, let's say type of a design, as a matter of fact. And a lot of protocols that we use here, and you have seen some of those protocols and policies, there are policies that are supported by non-Cisco devices as well. So you can have those kind of devices in your network. It is open source. Lots of APIs have been written for ACI, and we are going to talk about some of them later. We can have physical and virtual endpoints. Basically, we can connect to anything here. And by anything, I really mean anything. We can just connect to bare metal servers. We can connect to virtual machine managers. We can connect to routers, we can connect to switches, and we can connect to basically everything in our network. And the policies are abstract. That means that policies are applied to the whole fabric, and the whole fabric understand what is happening here. Now, one thing about ACI topology is the limits that we have. And of course, there is a document here, which I'm going to open it in a second, and you will see that. But in this document, what we see is the maximum number of, devices that we have. One thing about the scalability that I forgot to tell you is this. If I go back to here, this is my fabric. And this whole fabric is very much concentrated here. But I can have multiple of these fabrics, and let's say that there is another copy of this fabric here. We might have another fabric here, and all of them can connect to each other, and we can just call them different pods or different sites, and we are going to speak about differences between these two. But this means that again we have a scalability like this. Multiple data center locations can be connected to each other in this fashion. Now, going back to this, we can have a very high speed IP network here, and when I speak about high speed, I mean something like 10 gigs and 40 gigs are something usual in this kind of a design. And the links between these switches are going to be that high speed. Now, in a pod, you can have something like 6 spines. That's a maximum of 6 spines. And you can have 24 spines in a multi-pod environment, which means that if you have multiple locations and all of them are connected to each other in a pod fashion, different pod fashions, so you can have up to 24 spines for the whole data center. And minimum number of spines are going to be 2, and this is what we have in our topology in the simulator. What about the spines? We can have 400, what about leaves? Sorry. We can have 400 leaves in one pod. And if we want to combine multiple pods to each other, we can go up to 500 leaves in multiple pods, of course. And the number of physical ports is going to be so interesting. We can have up to 24,000 ports in each fabric, which means that almost endless. Almost endless. What about APIX? So Cisco says you can run the whole architecture with just one APIX, but Cisco says you should not do that. You should go with at least 3 APIX. And it says that the number of APIX should be odd. You should not have 2 APIX. Technically you can, but you should not have 2 APIX, because sometimes we want to have a quorum on the configuration and backup and things like that. So you need to have an odd number of APIX. So that's going to be 1 or 3 or 5 or 7. For each cluster, and again I'm going to speak about cluster later, but let's say that we have APIX configured in a cluster. We can have up to 7 APIX. And normally you can have at least 3 of them. And also, like I said, the design is in a way that leaves only connect to spines, spines only connect to leaves. So going back to the document here, you can check the document, and in this document, of course, there are lots of information, and this gives you scalability limits. These are basically what I have copied and pasted in my slides, but you can go to this document where I have put the links like right below that, and you can just check everything here in depth and just study about that. So for example, if we want to have fixes, and you know what fixes are, fabric extenders that can be connected to some of 5Ks or 7Ks, we can support up to 650 fixes in our network. So basically you can connect something like 24 fixes to Nexus 5K, or 32 fixes to let's say Nexus 7K, which means that you can have multiple fixes in your environment, and the maximum is going to be something like 650. We are going to talk about contracts, and this means that we need to, you know, revisit this page later, but you can have up to something like 10,000 contracts in your network. And basically contract means that you need to define some rules for connectivity between 2 parts of the network that you have. Like I said, we are going to speak about them, but let's say we have something like an endpoint groups, which means that a group of devices, whether they are virtual or physical, doesn't really matter. And we want to make sure that these devices can talk to other devices in another part of the network. For each one of them, we need to have a contract. So a contract is kind of a, let's say, rule to make sure that 2 entities can talk to each other. And here you can see that the number of EPGs, which means that endpoint groups, can be up to 15,000. And basically, if you want to have layer 2 fabric, that's going to go up to 21,000. Like I said, we are going to, you know, revisit this, and some of the things that you see here, you might really not have any clue about that. I'm going to explain them later. So this is the topology that we have. So let's speak about APIX in the next part of the video.